Let's express the solution set of this linear inequality in two variables. Remember, when you have a linear equation in two variables, you express the solution set through a graph because there are an infinite number of solutions. We could never list them all. So instead of trying to list them, we simply draw a picture of all of them, and that's our graph. We do the same thing for linear inequalities in two variables. We are going to express their solution set with a graph. And where we start is to first establish the line by first graphing the linear equation in two variables. So step one in expressing the solution set of a linear inequality in two variables is to express the solution set of the linear equation. I'm going to draw the line that's related to that equation. So let's find several solutions so that we can establish points and then draw the line. Well, what if I let x be 0? If I let x be 0, that disappears into 0, doesn't it? And wouldn't y have to be 5 to make the statement true? If x is 0, y would have to be 5. 2 times 0 is 0. 0 plus 5 indeed is 5. That solves the equation, doesn't it, if x is 0? Well, what about if x is 1? What would the solution be? What would y have to be? If x is 1, 2 times 1 is 2. 2 plus 3 would make 5. So if x is 1, y has to be 3 to make the left side equal to 5. What if x is 2? 2 times 2 is 4. 4 plus 1 would make 5. So y would have to be 1. So I have three solutions I can plot here on my graph. X is 0, y is 5. That's this point. If x is 1, y is 3. And if x is 2, y is 1. And we have the points. We can draw the line. And we draw the line in a solid fashion because we want the points that make it equal to 5, don't we? We want the points x, y that make this quantity greater than or equal to 5. So since I want the points that make it equal to 5, I draw the line in a solid fashion. We'll look at an example of what we have to do when we don't want the points that make it equal. We have to do something different with the line to indicate that the line is not included. Now I want to find those points on one side or the other of the line that make it greater than 5. So what we simply do is pick a point, just as we did in the previous video. We pick a point, plug it in to see what happens. And the real easy point to put in always, is the origin. As long as that point isn't on the line, that's the easiest point to try. That's the easiest point to test. Because 2 times 0 is 0, and 0 plus 0 is 0. So if I let x be 0 and y be 0, if I'm testing that point, I end up with 0 is greater than or equal to 5, which is a false statement. 0 is not greater than or equal to 5. 0 is less than 5. So these points do not solve the inequality. It's the points here on the other side, and to express that, I shade that other side. So the expression of the solution set of that linear inequality in two variables is this graph. The line is solid because I want the points that make it 5, and all of these shaded points over here make 2x plus y greater than 5. And that's how we express the solution set of a linear inequality in two variables. We do it through a graph in a similar fashion to what we do with linear equations in two variables.